Hello ladies and gentlemen. Today we're going to be talking about factoring polynomials. There's actually three different techniques that we'll discuss over the next 3 days. And the first one is factoring the GCF. Now if you look at our first example here, we have a binomial. 2x is our first term and 2y is our second term. Okay, we want to know what the GCF is of these two terms. We want to factor it out. Now yesterday in class we identified the GCF of two different terms by doing their prime factorization. So 2 times x for 2y would be 2 times y. We identified that they both have a 2, and we said then the GCF would be 2. Okay, so that's what we did yesterday, and you can certainly watch that video if you want a refresher on that. So what we're going to do here is we're going to factor this. We're going to prepare a distributive property problem, and then we are going to take each term and we're going to divide it by 2. So we'll take 2x, we'll divide by 2, the 2's cancel. We're going to take 2y, we'll divide by 2, the y's cancel. And our solution, which is actually a problem, is 2 times the quantity x plus y. So 2x plus 2y in factored form is 2 times x plus y. We can actually check this by doing the distributive property, and I'll do that in a different color. We do 2 times x is 2x. We do 2 times y is 2y, and that of course is positive. And you can see that by doing the distributive property, we've actually got back the original problem, and that's a way you can check these particular problems. In our second example here, we are told that 4r is the GCF of this. We'll be figuring out GCFs on our own soon enough, but we'll take advantage of this example giving us a little bit of help here. What we're going to do is we're going to divide both terms by 4r. Here the 4's cancel and the r's cancel, leaving you an s. So we'll put an s in here. Try to squeeze it in there. 4 goes into 8 2 times. The r's cancel out. And you notice there's a t there, so we're left with 2 and a t. I'll write that larger for you. So that is actually 4r times s plus 2t. Okay? You might want to pause the video a moment and use the distributive property to check that, and you'll see that we did factor it correctly. Okay. If you look at our third example here, if we go off on the side and do the prime factorization of 3x, which is going to be 3 times x, the prime factorization of 4y, which would be 2 times y. You can use a factor tree to help you with that if necessary. You will notice that there are no common factors in the two terms. We have a 2 for the 4y, but we don't have a 2 in the 3x. We have a 3 in the 3x, we do not have a 3 in the 4y. Same thing with the x's and the y's. They're kind of alone on an island there. They're not being shared by the two terms. This particular expression, 3x plus 4y, does not have a greatest common factor. It's already in factored form, and there's nothing we can do with it. It's perfect as it is. Alright, number 4. 5x, 5y. You'll notice that both terms have a 5, so there's definitely something we can factor out here. And when we want to figure that GCF out, we're going to need a 5. They don't have an x in common, they don't have a y in common, so your GCF is just going to be 5. So we'll prepare this problem for factoring. We will divide both terms by 5. 5's cancel, 5's cancel. We're left with x minus y. This is your answer. So your answer looks like a distributive property problem, and that is correct. Alright, here, take a look. We have 1/2 a(n), we have 1/2 ln. So you'll notice that both terms have a 1/2 and both terms have an n. And here's an example of us doing this without a factoring tree, without figuring out GCF off on the side, just looking at it and figuring out mentally. We're going to divide both terms by 1/2 n. Here you'll see the 1/2's cancel, the n's cancel. Okay, 1/2 goes into 1/2 one time, n goes into n one time, leaving you with an a. In the second term. 1/2 goes into 1/2 one time. N goes into N one time, leaving you with an L. So once again, just for the sake of review, we can take 1/2 N, multiply that times A plus L. 1/2 N times A gives you 1/2 A N. 1/2 N times L gives you 1/2 Ln. Get my plus sign here so you can see it a little bit better. And you will notice that our check, which is in orange, matches up with the original problem, 1/2 AN plus 1/2 Ln. So we did it correctly. Okay, moving on to example 6. Now, you have 6 and 12, so once again, if you cannot determine the GCF by taking a look at it, you may wish to go off on the side and write down the prime factorization, whether or not you need a factoring tree for that, and certainly have that as a tool in your toolbox if necessary. And with some proficiency, I think that you'll probably get to the point where you can do some of these easier ones without it. So 12 is 2 times 2 times 3. We have 2 C's and we have 2 D's. Alright, so we have to figure out what the GCF is. So you'll notice they both have a 2. We'll bring a 2 down here. They both have a 3. We'll bring a 3 down. Both have a C. We'll bring a C down. Both have a second C, which we'll bring down. And they both have a D. Okay, and if you look at what we did not circle, we have a C on top, we have a 2, and a D on the bottom. There are no other matches. So the GCF is going to be 6C squared D. So that's what we're going to take out of this. So 6C squared D times, getting a little messy here. We'll divide both of these by 6C squared D. And if you look at your GCF calculation over here, you'll kind of get a good idea of what's left over. 6 divided by 6 is 1. C cubed divided by C squared is D. And the D's cancel. In the second expression, we have a negative sign there, so let's not forget that. 6 goes into 12 2 times. C squared divided by C squared is 1. D squared divided by D is D. Now take a look at what we had left over here. We had a C, which does seem to be what we're left with there. We have a 2 and we have a D, 2D. So there is a correlation between these methods of finding the GCF and what you'd be left with inside the parentheses. Our final answer, 6C squared D times the quantity C minus 2D. Alright, number 7. 3x squared minus 6x minus 30. You'll know that notice there's no x here, so we're not going to factor an x out, and x will not be part of our GCF. Each of these terms is in fact divisible by 3, so why don't we just take that 3 out and see what happens. Okay, so 3x squared divided by 3. 3 goes into 3 one time. We'll be left with x squared. Negative 6x divided by 3. 3 goes into 6 2 times, so negative 2x. And 30 divided by 3 is 10. Now there's a negative sign there, so don't forget the negative sign. So our final answer, 3 times the quantity, x squared minus 2x minus 10. Here in example 8. Now you do see, if you take a look here, we do have an A in all 3 terms. Alright. We also have 3. 3 goes into 6, 3 goes into 9. So what we're going to factor out is a 3A. Alright, so we're going to divide all of these by 3A. 3A, 3A. 3 goes into 9 3 times. Of course your A's are going to cancel out. A divided by A is 1. So we're left with 3B squared. 3 goes into 6 2 times. The A's cancel out. So you have negative 2B. 3A goes into 3A one time, so we're going to have negative 1 on the end. The reason this has a star is because of this negative 1. You should actually always have the same number of terms in your parentheses as the original problem. 9AB squared is a term, negative 6AB is a term, negative 3A is a term. So the original problem had 3 terms, And you'll see our solution has 1, 2, 3. You can think of that negative 1 as a placeholder there, but that third term should be there. Problem 9. Well, look at what we have here. We have 4 A's, we have 2 A's. Okay, our largest A we can take out of both of these terms is going to be A squared. Okay, 2 B's and 2 B's, we can take that B squared out of both terms. 3 C's and 2 C's. The largest number of C's we can take out of both terms is going to be 2 C squared. Okay, largest number that goes into 8 and 12, once again you can do a factoring tree to figure this out, is going to be 4. Okay, so doing some of this stuff mentally, trying to think of what number goes into 8 and 12, the largest number. We're going to divide each of these by 4, A squared, B squared, and C squared. Okay, 4 goes into 8 2 times. 4 A's on top divided by 2 A's on the bottom. That's going to leave you with A squared. The B's cancel. And 3 C's on top, 2 on the bottom. That'll leave you with 1 C. So 2 A squared C. Alright, the second term here, we'll divide that by 4 A squared, B squared, C squared. 4 goes into 12 3 times, so we'll have our 3 come over here. A squared divided by A squared is 1, B squared divided by B squared is 1, C squared divided by C squared is 1. So 3 times 1 times 1 times 1 is just 3. So our final answer here, 4A squared B squared C squared times the quantity 2A squared C plus 3. And once again, you can check it. You can check it. Multiply powers with the same base, you add the exponents. Should pause this video maybe and take a second and go ahead and do that. Check it, make sure you did it correctly. Alright, problem 10. In problem 10, we have 28 and we have 70. So what a great opportunity to do a factoring tree, just to review that. 28 is 4 times 7, 4 is 2 times 2. So 28 M4 and cubed is going to be 2 times 2 times 7, and then we have 4 M's and 3 N's. Squeeze it in there. There we go. We can move this over a little bit. And 70 is 7 times 10. 10 is 5 times 2. Or 2 times 5, I guess. I'll write it like that. 2, 5, and 7. So 70 M squared M to the 4th is going to be 2 times 5 times 7. And then we have 2 M's. We have 4 N's. 1, 2, 3, 4. Okay, so figuring out our GCF. Switch to green here for this. Let me know in class if green is difficult to see in the video, and I'll go with something else in the future. 2's, 7's, M, another M. We have no more M's, so we'll go to the N's. N, N, N. So 14 M squared N to the 3rd power. So going back over here, this is going to be 14 M squared N to the 3rd power times. Now let's take advantage. Now we did this GCF calculation over here. Take a look at what you did not circle. 2mm. That's 2m squared. Okay. And on the bottom, what didn't we circle? 5, and we did not circle n, so 5n. If you have to take the time, because of the difficulty level of the problem, to go with a factoring tree, to compute a GCF like we did here, it's a longer process. Well, why don't we use it to help us figure out what goes in the parentheses? Okay, and that way we can reuse this information and save ourselves a little bit of time. So once again, we can check that. Okay, we do 14 times 2m squared, that becomes 28. When you multiply powers with the same base, you add the exponents. I mentioned it earlier. So that's 28 m to the 4th n cubed. And then we do the second one. We have negative 70 m squared n to the 3 plus 1 power. Remember, you can put a 1 there if you wish. So minus 70 m squared n to the 4th. And that is the original problem. So we did it correctly. Let's box this up. So using that GCF to help us saves a little bit of time. Okay. Our last example here is a little bit different. Okay. We are going to do something called factoring by grouping. Factoring by grouping, which is a slightly different factoring technique. It still is all about GCFs, but you'll see it's going to look a little bit different. This is going to be a very important technique. So as we're moving forward, we want to master factoring by grouping. Okay, so here's what we're going to do. Take a look at the first two terms, AV minus AW. Okay, there is a GCF just in those terms, and you can take a moment. What is it? You're right, it's an A. So we're going to take A out. We're left with V minus W. If we look at the second pair of terms, BV and BW, you'll notice that there they have a GCF as well. It's B. We take it out, V minus W is left. Okay, this is a step in a longer problem, so this is not the answer, but we have certainly identified that both AV minus AW and BV minus BW share a V minus W. Well, let's take it out. If I take V minus W out of A times V minus W, I'll be left with A. If I take V minus W out of B times V minus W, I'll be left with B. And it turns out that the final answer to this problem, the final factored form, is V minus W times A plus B. And that concludes our lesson for today. Please remember to bring your textbook to class. I look forward to seeing you tomorrow.